Good morning, students. Today we are going to discuss the case study problem on Jordan canonical form. First, to find all the Jordan canonical forms of the matrix having matrix A having characteristic polynomial chi A of x equal to x minus 3 whole power 4 into x minus pi whole power 4, and the minimal polynomial ma of x is equal to x minus 3 whole square into x minus pi the whole square. Now here the characteristic polynomial is chi A of x is equal to given x minus 3 whole power 4 into x minus pi the whole power 4. Here the eigenvalues are lambda equal to 3 and lambda equal to 5. Now order of the matrix is nothing but the power of the characteristic polynomials 4 plus 4, that is equal to 8. So therefore the matrix, the order of the matrix that we are going to construct must be equal to 8. The minimal polynomial, the highest order is 2. So therefore here m equal to index of the powers in minimal polynomial, here m equal to 2. By the Jordan block property, so there is at least one Jordan block of order m equal to 2. இப்போ ma of xல பார்த்தீங்கன்னா அதனுடைய ஐகன் வேல்யூ வந்து lambda equal to 3 and lambda equal to 5. So therefore the power of x minus 3 is 2. That is the value of m. I mean the power of x minus 5 is also 2. That is also m equal m. So therefore here m equal to 2 for 3 and for 5. So there is at least one Jordan block of order 2 corresponding to the eigenvalue lambda equal to 3, and similarly there is at least one Jordan block of order 2 corresponding to the eigenvalue lambda equal to 5, and the remaining blocks of order less than 2 அந்த மாதிரி வரணும். இப்போ பாருங்கள் இந்த டேபிள் பார்த்திங்கன்னா ஹியர் இப்போ பாசிபிள் ஜோர்டான் canonical ஃபார்ம்ஸ்லாம் பார்த்திங்கன்னா ஹியர் there must be lambda equal to 3ல the order of the matrix characteristic polynomial consider பண்ண at a time you consider minimal polynomial also. So for example first உங்களுக்கு வந்து minimal polynomial if you take lambda equal to 3 eigenvalues are both eigenvalues are happening in here in a characteristic polynomial and minimal polynomial the eigenvalues are same, lambda equal to 3, lambda equal to 5. Here also lambda equal to 3, lambda equal to 5. Now you have to take the possible orders. The order should not exceed 8, and similarly in while comparing to previous one பார்த்தீங்கன்னா chi A of x corresponding to lambda equal to 3, maximum power is 4. Similarly in chi A of x corresponding to lambda equal to 5, the maximum value is 4. So therefore the orders should not with respect to chi A of x it should not exceed 4. Similarly with respect to ma of x the order should not exceed 2. So both conditions must be satisfied. Order of the matrix 8 இருக்கணும், and at the same time chi A of x power and as well as ma of x power must be should not exceed the limit. So அதை வச்சு நம்ம என்னென்னா based on this we have to consider the possible partition values we have expressed here. First you take there are 4 possible forms exist. One is lambda equal to 3, lambda equal to 5. 2, 2 with respect to MA of x. With respect to chi A of x also, you will get 2, 2. So there are total value is 8. Here we can frame 4 Jordan canonical forms. 4 Jordan canonical forms. You take first one. First one, there is an with respect to uh, minimal polynomial MA of x, lambda equal to 3, we have formed a Jordan block of order 2. Jordan block is nothing but order 2 means we are corresponding to the eigenvalue lambda equal to 3. So you take the eigenvalue lambda equal to 3 and order 2 you have to frame along the diagonal entries you write 3 3 and above the diagonal entry you write 1. So therefore see here in the first matrix 3 1 is the 3 1 1 block. Corresponding to lambda equal to 5 you write 3 1 0 3 and you take lambda equal to 3 for chi A of x. You will get 5105 and similarly for chi A of x you get for corresponding to lambda equal to 5 you get one more block 5105 and next you take second form. In the second form lambda equal to 3 you are having you have to construct a Jordan block of order 2. So that is 3103. Similarly, for lambda equal to 3 with respect to chi A of x, you have to form a single block of order 1 1. So single block of order 1 1 வரும்போது பாருங்க 3103 again 3 3 அது மட்டும் in the second format. And then you come back again for eigenvalue 5. Eigenvalue 5 க்கு பார்த்தீங்கன்னா you have to construct Jordan block of order 2. So therefore 5105 and for lambda equal to 5 once again you have to construct a single block of order 1 1. So therefore 5 5. So this is the second format. Similarly in third format பாருங்க corresponding to MA eigenvalue lambda equal to 3 with respect to MA of x அப்போ we have framed a Jordan block of order 2. So therefore 3103. அதே மாதிரி எடுத்துக்கிங்க வந்து ஃபார் கரஸ்பாண்டிங் டு chi A of x lambda equal to 3 you have to construct a Jordan block of order 2. So therefore there also you have framed 3103. Next we come to eigenvalue lambda equal to 5. You have to construct a Jordan block of order 2. So therefore 5105. Next with respect to chi A of x you have corresponding to eigenvalue lambda equal to 5 you have to construct a single block for corresponding to eigenvalue lambda equal to 5. So therefore 5 5. And similarly in the last form you are corresponding to eigenvalue lambda equal to 3 for the characteristic minimal polynomial you have to construct an Jordan block of order 2. So therefore 3103 and come to chi A of x with respect to lambda equal to 3 you have to construct single blocks of order 1 1. So therefore we have constructed 3 3. Next you take 5 எடுத்துக்குங்க with respect to MA of x you have to construct lambda Jordan block of order 2 for the eigenvalue lambda equal to 5. So 5105 for lambda equal to 5 and then take for lambda equal to 3 you have to construct one more single blocks, two single blocks. So we have constructed 3, 3. And next to come to eigenvalue lambda equal to 5 for MA of x. You construct Jordan block of order 2. So therefore you will get 5105, and you come to chi of x, characteristic polynomial corresponding to lambda equal to 5. You have to construct another Jordan block of order 2. So therefore 5105 we have constructed. The remaining all the entries are 0. So this is the possible Jordan forms. Next, we study the Jordan canonical form. One more problem. Find the Jordan canonical form of the matrix A equal to 0, 4, 2, minus 3, 8, 3, 4, minus 2. First, we construct the characteristic polynomial. Determinant A minus xi equal to 0. Substitute the A matrix value, x value. I value is unique matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Next, we solve the equation using algebraic operations. You will get the final equation as x cubed minus 6x square plus 12x minus 8 equal to 0. Now, randomly you substitute x equal to 2, the equation will be satisfied. So, therefore, the x minus 2 is a factor. And using the synthetic division, we can find x minus 2 whole square is also another factor. So, therefore, characteristic polynomial chi a of x is equal to x minus 2 the whole cube. The possible minimal polynomials are x minus 2 whole square, x minus 2 whole cube. So we have usual method. We by which the polynomial which satisfies the Cayley-Hamiltonian theorem will be the minimal polynomial. So we check for first A minus 2i. Replace x by the matrix A and 2 into I, unitary matrix. You find the A minus 2i matrix which is not equal to 0. Therefore, x minus 2 is not a minimal polynomial. And while we are checking A minus 2i whole square which is equal to 0. So therefore, here minimal polynomial is x minus 2 the whole square is the minimal polynomial because it satisfies the Cayley-Hamiltonian theorem. So therefore, chi a of x is equal to x minus 2 whole cube and ma of x is equal to x minus 2 the whole square. By Jordan block property, there is at least one Jordan block of order 2 because the index of ma of x is here is 2. So therefore, another remaining Jordan blocks of order must be less than 2. So now here the characteristic equation, order of the characteristic equation is 3. So therefore we can construct a matrix of order 3 only. So therefore by minimal polynomial there is at least one Jordan block of order 2. So which is constructed here j equal to 2 1 0 2 and remaining one will be only one Jordan block, single block. So here 2102 0 0 210 020 002. Students, I hope that you understand the Jordan block concepts well. Thank you.